What are you doing? This is recording, this is recording. I don't want to stop talking.
Funny.
You don't even know what he's talking about. This is a You're back.
Okay, today we're going to learn function compositions and operations. Yes, Leslie? This is 13 today. 13. We did 12 yesterday.
Oh my god, we did that. Oh, true.
You good?
We started with 10
How many concepts are in this year?
or 9.
In this unit, we have 13, 14, and 15 left. After concept 15 is your second test. So we have today and tomorrow is going to be 13. I'll tell you that already. It's going to take us 2 days at least. Then next week on Monday, do you work on Monday next week?
No.
Okay. On Monday will be 14, and that's only 1 day concept. On Tuesday will be 15, that's also only 1 day. Wednesday, okay, so then Wednesday will be 15. Thursday we review, and then your test will be the following week. Okay?
Tuesday.
Because you work on Monday the following week, so then it will be Tuesday. Okay? Because you got a 4-day weekend before the test comes around. That's a tough one. Please remember that. Okay. So let's take a look at function compositions and operations. First, think of the word composition. What do you think of when you hear the word composition?
Compose.
Good. Compose, right? Somebody asks composer. What do?
Write it together.
They put something together or they write it. Very good. So what we're doing today is we are going to compose or put functions together. Okay, just like the word composition means, we're going to compose functions. We're going to put them together. So our goal today is to be able to take a function like f of x and another function like g of x and to say if we combine them, what is our result? Okay, we're going to first look at our 4 operations of math. Then we will look at compositions. Who can tell me, what are the 4 basic mathematical operations?
Subtraction.
Alright, now, I heard many of you, but again, adding, subtracting, multiplying, dividing. Remember, please, adding and subtracting are really the same thing. We always say that, because you're adding the opposite. Division and multiplication, you're multiplying by the reciprocal. So we really only have 2 major operations, but we consider them to be 4. Okay? Really, it's adding and multiplying. Those are the real operations we have. The others are just adding the opposite and multiplying by the inverse. So, let's start. Let's say we have f of x. We'll define f of x as 2x plus 4. And we'll say that g of x is... Well, you know what? I'm going to go straight off the notes so you guys, in case you're referencing the notes, you have the same numbers. 2x minus 5 and negative x plus 4. Right? So we have 2 different functions now. One is f of x, one is g of x. Yesterday's lesson we talked about evaluating the functions or finding the height of the function where we plugged in the x. We will get back to that actually toward the end. But before that we're going to look at only variables, no numbers yet. So if I asked you, tell me what f of x plus g of x is. What is this asking me to really do?
Find x.
Not find x, no.
Why?
Kelly?
To find f of x and then g of x and then add them together.
But I have f of x and g of x, so what am I just doing?
Oh, then you're just
Add them
adding
together.
Good. I'm just adding the 2 representations together. So I'm taking this one and I'm adding it to this one. Again, when I add functions together, I'm just going to be combining like terms. So let's write them first.
X minus 1.
This is negative x plus 4 over here. What'd you ask, Karen? Sorry?
I thought, no.
Oh, you're asking the final answer.
Yeah.
Okay, we're getting there, yeah? We've got f of x plus g of x. Again, this is g of x over here. This is really f of x over here. Now, when I combine these, I need to combine my like terms. So when I think of like terms, this is a like term with this entire like term. This is a like term right here, and this is a like term with it. Okay, so when we do this answer, we're going to say that we have the 2x and a negative x. What does that give you?
X.
Just x. Again, remember, this negative x is like a negative 1. So you really have a 2 and a negative 1 together.
So x.
So 2 plus negative 1 is just positive 1. Again, 2 plus the negative 1 is positive 1 over here. Then I've got a negative 5 plus a 4.
Negative 1.
Negative 1. Again, negative 5 plus 4, which gives me negative 1. So I put minus 1. So my final answer for this one is just x minus 1. So again, all we're doing here, if you want to write notes down, for adding and subtracting, we are simply combining like terms. Again, adding and subtracting, which we're going to do subtracting next, we are just combining like terms.
I have a question.
Yes.
On the other side, the equal sign is that a y. When your y equals x plus 1, then you will grab it.
It's still just this. It's still just, that's all it is. We're just saying f of x and g of x together give us this. You can redefine f of x and g of x together as like h of x and then call it that if you want. Okay? Next one, so that was adding. Subtracting. Is it going to be any different really?
No.
Same process, but just a different answer. So instead of this one, now we have 2x minus 5 minus negative x plus 4. Now, I don't want to deal with minus. So what should I do instead? Good. Change the signs and add it. So let's think of this as adding the opposite. Once again, take a look. I made this a plus sign in the middle, and instead of negative x plus 4, now it's x minus 4. I switched both of those signs because I'm adding the opposite.
You wouldn't have to change the first one.
Absolutely not. Very good. Again, when you're subtracting the second term. Thus, when you change it, you only change the second term. Okay? So we're only changing this one over here. Now, combining like terms again. The 2x and the x are combining to?
3x.
Very good.
Minus 9.
Negative 5 and negative 4, good, is negative 9. And again, we can carry this down the whole way. Again, remember what these quotes mean. The quotes mean repeat what's above. So you're repeating the previous line. That's what those mean on the left here.
Wait,
So this carries down the whole way on the left side.
I got confused at everything after you started doing the blue marker. Like, how did you get 2x minus 5 plus x minus 9?
I made, instead of subtraction, I did adding the opposites.
Oh, okay.
See how this is subtraction? I made it plus, and then I
Oh.
switched these signs.
Yeah.
So this entire thing, this negative here, became a positive. This positive became a negative.
So, okay, I got
And
it.
then I switched the sign in the middle. Again, because subtraction is adding the opposite. Now that is addition and subtraction. Let's move on to multiplication next. I'll give you guys another few seconds here. If you run out, if you don't get it down, again, it's re-recorded. You can always check on it online later if you missed a quick note.
How come the first pair didn't get switched?
Because we're only subtracting the second part, right?
Oh,
So when you subtract the second part, it means you're only changing the second part.
Alright.
Look back to concept 1, actually. That's where we went over this, okay, if you're having trouble. Take a look at your notes in there. All right, so we're going to multiply now. We have, again, still 2x minus 5 and negative x plus 4. Now, who can tell me about this part now? What process must I use? And be careful here. Anthony? Foil. Foil or box method here. Because you're multiplying two things, each of which happen to be binomials. So we have, really what we're doing is 2x minus 5 times negative x plus 4. And clearly they are both binomials because each of them have two terms, and we're going to multiply them. So we have to foil or box. Remember, FOIL, 2x times a negative x gives me negative x squared. Okay, don't forget the x squared there. Next, outer. Inner. And then last. Okay, if you can do this in your head without putting the separate terms in the middle, that's fine, do it. Okay, sometimes it gets a little more
How
difficult.
did you get 8?
The 8 comes from the 2x and the 4. It's the outer part of FOIL. So if I combine the middle two terms, I'm going to have a 13 there, right? Hey, where did the 5 come from? 5, negative, negative 1 gives me positive 5. The negative 5 here and the positive 4 gave me the negative 20. Okay, be careful of your signs again, people.
So that's what we leave it to.
And we leave it like that because look at our terms. Do we have any other like terms to combine? We're all done. We combine our middle like terms, you have to stop there.
They're gonna pull back again? Oh, no,
You get back to the beginning, right?
Yeah.
And that's factor. Okay, factor is the word. So here, what's the last operation again? Division. So let's try f of x over g of x. Now, if I'm going to write f of x over g of x,
Subtract. Let's subtract. Multiply both sides by the denominator.
okay, hold up, let's see. That's what I have, right?
Negative x minus 4 times both like numerator denominator.
Now, you only have to do that if you're working with,
Radical.
complex numbers or radicals. So binomial conjugate or complex conjugate. Here, you don't have to do that. Let's go through this. For this problem here, I actually can't go any further. Here's why. Everybody see how there's a plus or a minus sign in the middle here?
Yeah.
That means that the numerator is composed of two different things that are being added together, or in this case, subtracted. These are called addends. Again, this and this together are called addends. This and this together are addends. If you only have addends, you can't cancel. You can only cancel if you have factors. Factors are things that are being multiplied together. For example, so I'm going to stop there for this one because you can't go any further actually. But I'm going to show you another example where, if you had the opportunity to, you could go further. So let's say the example, instead of looking like that, let's say our example ended up with x squared plus 6x plus 5 all over x plus 1. Immediately it looks like they're all addends and you can't cancel. Again, I cannot cancel these x's here. Please don't do that. And we'll go over this process later on in the year. But if I look at the numerator, what can I do to the numerator? Again, only the numerator, what can I do to it? Factor it. If you can factor the numerator, do so. Because then what we'll notice is we see things that might cancel out. Factoring the numerator, what do I get?
X.
5, x plus 5, x plus 1.
Good, I heard several of you get it at the same time. x5 and x plus 1.
How did you get 6 and 5?
Let's go through it. This is a whole new problem. Whole new problem.
Oh, it's a new problem?
Yes, Manuel, totally new problem. Try 3 and 2. That would be if these were switched. Again, they must multiply to give us this and add up to this. If it was reversed, then it would be 3 and 2. Now, take a look here. At this point in time, the x plus 1 on the bottom looks like an addend. It doesn't look like a factor, but really, take a look. It's like there's a 1 outside if you're multiplying. That's what's really going on the bottom. So now, I can cancel this. Again, because now I have factors. These are multiplying, these are multiplying. You can always cancel factors, whereas earlier, we had just addends. We could not cancel addends. Again, the final answer over here would just be x plus 5 now, right? It would be over 1.
Is that a 1 right there?
That is a 1 right there, yes. And I just put that there, Dan, to show that there's really a number multiplying this whole thing, which is what makes it a factor. In the end, the final answer is really just x plus 5. Okay, even though it's x plus 5 over 1, because anything over 1 is itself. All right, so as far as operations go, adding and subtracting, combine your like terms. If you're multiplying two functions, you might have to FOIL. Okay, and if you're dividing, and you can't go any further like this example we have, you just leave it alone. Are we okay with that so far?
Yes.
All right, that's our operations. Now let's go over to compositions. To do compositions, the easiest way to think about it is like yesterday's lesson. So I'm going to go back and talk about that for a quick second. If I had some function of x, and that function was defined by 3x plus 2, and I asked you, tell me what the function value is when x equals 3. What do I have to do with that 3?
Plug it in for x.
Good. Plug it in for x. So I say 3 times 3 plus 2 gives me 11. Again, what did I do? I took this value and I plugged it in right here. Just like yesterday when we evaluated functions. Now, it is no different what we're about to do than what we just did. But this 3 is no longer going to be a 3. Now it's going to be a variable, or it's going to be another function inside of it. So instead of a number that's going to be plugged in, we're going to plug in another variable, like maybe a squared plus b, or another function like g of x we're going to plug into here.
It's gonna be the equation.
So in the end, we're going to end up with another function or another equation. We're not going to get a number answer this time.
It's gonna be like a function, like
Say it one more time?
it's gonna be like a function, like two multiplying functions.
Not multiplying, but composing, and then they're different.
What about if it's gonna be like a quadratic function, quadratic equation, and then another function, right?
If you have a quadratic and then a linear function, we'll see what we get. Give me a second, and I'll answer that, okay? 'Cause I'm not sure what you're asking me. Give me 1 second.
Yeah, you could do it.
I think so.
You can't do it. So, yeah, no, you have to break it down. So how'd you get the 3 in the FX on?
It was given, it was given. So, like that, okay? All right, take a look at this example now. Looking at this example, we have a function f of x, and we have a function g of x, okay? My question for you is the following. We want to find f of g of x, okay? We want to find f of g of x. Now, if we think back to the last example, when we found f of 3, we just plugged the 3 in. Agreed?
Yeah.
So now, instead of plugging the 3 in, I'm going to plug g of x into f. Again, earlier we had a 3. We took this 3, we plugged it in up here. Now we have g of x in here. So this means I'm taking g of x and putting it into f of x. So start by rewriting f of x. But don't put the x in. Just leave a blank there. Again, last example, we would have plugged in a 3 into that blank, or into that parentheses. But now my question for you is, what if you plug in g of x? What do you get? But what is g of x defined as on here? Negative 3x plus 1. So what we have to do is take that negative 3x plus 1 and place it in place of the original x. Again, what we are doing is we're taking this g of x right here and plugging it in right there into that x spot. And think back to evaluation. You would have done the same thing, but earlier we had numbers. Don't let this confuse you anymore. It's the same process. If you had a number, you would simply plug the number in for x. Now we don't have a number. Now we have another function. So we must plug this function into x. Now, we could just write g of x here, but we know g of x is negative 3x plus 1. So we plug in that entire function, and then we simplify. So we end up with negative 6x plus 2, good, which is? Minus? Okay, negative 6x minus 2. Again, just to restate this, we are no longer taking a number and putting it in for x, we're putting another expression in for x. That expression in this case was negative 3x plus 1. Again, that expression, okay? That expression here was negative 3x plus 1. Okay, now let me try, can we drag this down a little bit? Oh, it's on the left side, okay. All right, continue with this problem. Take a look at the top still. Now what I want to do, using the same functions up top, find g of f of x. Again, using the same functions from the beginning, instead of finding f of g of x, now let's do g of f of x. So in words, before we start this, can somebody tell me what I need to do here? In words, Karen.
So you would do 3x parentheses 2x minus 1 parentheses plus 1.
Okay, good. So what are you doing? Count
You're
them.
plugging in fx,
Into?
g of x,
Very good,
g of
Karen.
f of x.
Very good. So she's plugging f of x into g of x. Same as last time. We're taking f of x and plugging it into g of x. So start this one again by writing g of x down. It would normally be negative 3x plus 1, but we no longer have this x up here anymore. Again, because we are replacing the x with an f of x. So we need to now take our 2x minus 4 and place it in over here. Again, where does that come from? 2x minus 4
Right here.
is right there for f of x. So again, what did we do this time? We took 2x minus 4 and we plugged it in right there for that x value.
It's gonna be, I guess, like x plus 7.
Negative 6x minus 11.
No, that's the thing.
Oh, that's it.
No,
Yeah, that's what I
make
got.
a mistake.
Relax, relax.
Boy.
Again, if you are writing in words down, here's what you should be writing. If you're writing this in words, you write replace x in g of x with f of x. You're replacing the x that was in g of x with the new function f of x. Hey,
How'd you get X
can I get what?
on the X right there? How'd you get 4?
Whoa.
This right here?
Whoa.
This whole function?
If I knew this during the PSATs, this would have helped.
Well, what about the
I replace
Hold on.
the
Wait,
x,
Don't change it. Don't
replace
change
that
it.
x
There was one question.
with this. Guys, relax, relax.
I'm trying to see which row.
I'm not changing it, don't worry, I'm trying to explain it. So we're replacing the original x that was in g of x. So whatever's out here, we're rewriting that. We're replacing this x with the 2x minus 4. Because the 2x minus 4, isn't that what really f of x is? From up here?
Yeah.
So we're replacing this value in for that x. So this x is now gone. This x has become 2x minus 4. Okay, we're going to do a bunch more, so we'll have more time to go over this. Again, make sure you're replacing the x value. You're not like just putting it in there and keeping the x. That's the common mistake I saw in the other class. Okay? Some people in the first period class, what they did, they would put this value in, but then leave the x. You're not doing that. You are replacing the x. Think about the function evaluation from yesterday. If you plugged in a 2, did you leave the x behind? No. You plugged in a 2 and that was it, and then you got a number. So the same thing goes here. You're plugging in a value.
I'm missing.
Anthony, what's up?
Alright, alright, so, alright, so, you know how, g of x, right? So you like, you put g of x into f of x?
In the first one, yes?
Yeah. So, what you put like, this is what I asked last week, but like, I want to clarify. Like, I always try to think about like, what you change the negative x plus 1 it's like 2x with like,
What are you talking about?
This? To this, you're asking?
Alright, we can
Guys, I can't hear him ask a question. We need to be quiet.
This question is.
No, I know what you mean.
Go ahead.
You want to ask me after class?
Yeah.
Okay. Again, though, he's asking a question, people, please. Let us try same ones, same f of x and g of x.
Oh my god, you got a problem. This what you mean? This what you mean?
Yeah, that's what I'm
Yeah.
saying.
You're so smart.
We're recording, stop talking.
Now, what if you were asked, instead of f of g of x, to find f of x?
Oh,
Okay?
when you just spoil
You just put 2x, yeah, you,
Oh.
no.
Oh, you use boy?
No.
And then he, oh my god.
You just put 2x.
Oh, I know
You
that
put
too.
2x minus 4 in the parentheses, huh?
Okay, let's say in words what we need to do here. First, you guys have good ideas.
Ooh.
We are going to,
2x minus 4 parentheses.
we are taking f of x and we're replugging it into f of x. So, we are actually taking this function and plugging it into itself.
You don't need G of X at all.
Okay, you might have said it, but hold on for a sec, and let everybody catch up. So the original function was 2x minus 4. Again, f was 2x minus 4. But instead of x, we need to replace that with f of x, which is again 2x minus 4. So we are plugging the function into itself. Again, we are taking this function, 2x minus 4, and placing it in for that x value. That's all we're doing. Again, that's what this says here. Place f of x in for the x in f of x.
Is it 4x minus 12?
What's 4x? Oh, snap, no, it's not. X,
Okay.
right?
Again, please be careful what you're doing here. I don't even care what the final answer is here. I want you to get it right, but I want you to see that you're doing it right. So the idea is that you are replacing something. You're replacing the x value in f of x with f of x this time. So you're taking this original, rewriting it, but wherever you saw an x here, this circle here, this red circle, that is replaced right here with this value, okay? Yes?
How do you get 4 minus 1?
Because the original function was 2x minus 4. This is like 2x minus 4. See, watch my hands. This 2 is that 2. This x is that whole quantity. Minus 4, minus 4. But instead of an x, I'm replacing it with f of x, which happens to also be 2x minus 4. How'd I get the 12? Negative 8 and negative 4 together gives me negative 12. Okay, let's try another one now. What if we have okay? You're given g of x. You're asked to find g of a plus b. Now, again, think about last time, guys. Think about yesterday. Whatever appeared here is what went in for x yesterday. Remember the numbers? Well, a plus b appears there now. So just put that in for x. You do. Now again, where did this come from? This came from the fact that we are evaluating g at a plus b. So instead of putting an x in right here, instead of that x, now we have this a plus b. And again, distribute as always. And we can't go any further though this time. I can't go further because I don't have like terms. Again,
Hold up.
I don't have like terms in this one.
So you just need a.
God bless.
G of X is
It came back to me one.
3a plus 3b plus the 7. Again, all that is happening, all that's happening here is substitution method, guys.
Do you do another example?
I'll go back at the end, all right? Just leave a space for it. This one's going to take you a little more work to do. Try it on your own. It's a little bit more challenging.
Oh my god.
I don't know what to do.
Same steps as last time. The original function is defined as h of x. I want to know what is the value of h of c minus d. Make sure your first step is correct, and then from there you can continue if you'd like to flow out. Again, the original function had an x in it. That x was replaced with c minus d. So look at the original function, replace that x with c minus d. Now, the common mistake here would be to see a square and a square root and try and cancel. You cannot do that because, again, here, there's a subtraction, which means these are addends. You would need factors again, like last time. So C minus D, C minus D, minus 2. What method must I use? Good. Boil it or box method, either one.
That's the answer?
I want you to do that, yes. Again, I'm showing the steps here for FOIL just so we have no confusion. If you go right to the answer, that's fine. So first, outer, inner, last. First will give you C squared. Outer will give you negative CD. Inner, negative CD. Last, positive D squared. And don't forget the 2 at the end, the minus 2. Combine the middle two terms, and from there, you have no like terms left. You can't go any further.
What happened to x squared?
What happened to x squared? You tell me.
I'm guessing it turned into c minus d.
Good guess. Why did that happen?
Because
The original function was defined as f of x, h of x, right?
yeah.
And now we're looking at h of c minus d, which means c minus d, this whole value,
Yeah.
takes the place of that x right there.
You
Okay.
can move it.
You can always go. It
It
makes an once you pick up the pen, it makes an object.
See, when you look at him, he doesn't do it. When you weren't looking.
Actually, the other teachers don't know how to work that.
Oh my god. Don't play with me like that.
Oh my god. You have to show.
You're like the only teacher who really does know how to do that.
You know, you can do, there's so much stuff you can do with this stuff, guys. You can throw them around and it'll like bounce around and stuff.
Do it.
Do it.
You have fun. You have fun.
Oh, we lost it
You're
now. Hold
listening
on.
recording, right?
Yeah, that's alright. You can do a lot of stuff with it, guys. There's a lot more than just that. Now, sorry, there's no laughing around this I forgot.
For real?
I don't know what she was, what were they asking for?
Actually, put it intended.
Oh, is that fine?
She said,
She just be like.
wait, don't take the picture. You just decided to say that and.
We gotta do one more though before we quit. One more.
Wait, hold on.
Yes.
Since you had shoes on all day, they pressed her out. Go press her out.
It's first outer to left.
Oh, you go hard today. You go hard
And
today.
your C times negative C. When you do the negative D times the C.
I'm gonna tell
That's
Yes.
you.
And then the D times
I'm gonna tell them
the C.
That's why
Alright, one more. Alright, one more. What if? What about this one then? Think about what we've done today and what we did yesterday. Again, think about what we've done today and also what we've done yesterday. Try it out. Tell me what you got. Try it out.
Oh no.
Stop that.
Diana, that was so ugly. Remember 16? You ugly.
Oh, you were
She thought you were playing.
I
I
know.
was
Yeah,
I was
this
just
one.
looking at her.
I didn't get none of that. She'll watch the video.
Oh my god, Diana is so funny.
Oh my god.
Oh my god.
Yeah, I know where it is too.
Ow.
we know
Everything was easy. This one, what do we do this?
I was like, oh, I'm gonna be late for
And then what do you do with that?
Do you be used to like a long-term student?
Sure, or just put an 8 in there instead. Doesn't matter which one.
You plug it in inside. It works. It works.
That's fine. That's an easy way to do it. That works every time. Let me show you something that makes it easier.
And then it was like that, and then you put three in for the
Hey guys, what does H of 3 mean in the inside? It means what?
three.
Put a 3 in up here, right?
Yeah.
So let's do H of 3 first. Agreed?
Yeah.
That's what H of 3 is. But that's only H of 3. We want F of H of 3. So this is really saying what's F of 8? Again, we evaluated H of 3 a second ago, didn't we? H of 3 was 8. So if H of 3 is 8, replace the H of 3 with an 8. Now do F of 8.
23.
So we're going to get 2 by 8 plus 4, or 20.
Yeah.
Check it again, Andrew.
So it would be F of 8.
Again, work the inside first, take that answer, work it into the outside one. It'll work every time. Just work your inside out, and then work your way every time.
Oh, okay.
Whoa.
Karen?
It would be F of 8
Ah.
equals 20.
Got it.
It would be, yes, which is the same thing as F of H of 3 equals 20, yes.
So you have to put F of 8 or not.
You don't have to, you could do it in your head.
No, but I'm saying you just thought about No.
You can write it like that, or you could say it's F of H, either one. Okay?
Where did you get 4?
Where did the 4 come from? Right up here. I took this 8, I plugged it in right up there. 2 times 8 is the 16, plus the 4, bring that down.
So you have to do H first.
Pretty much.
Alright.
Guys, you gotta do H first here. Do H first, then move that out to the outside one.
So 3x minus 1, that x is a 3.
Because that's what the 3 said right here, right?
Oh, okay. Oh, okay.
So this 3 went in up there. You got that answer. You then took that answer, plugged it in up over here.
Okay.
Okay?
I love this chair, man.